Okay, so dito sa last part, magta-try lang tayo ng sample problem, and then sa lab, of course, pwede tayong magkaroon pa ng mga additional problems to do. By the way, yung sa last slide dun sa activity, pagpatawad nyo na kung medyo hirap ipagkasya dun sa slide um, yung process diagram for bacon. But generally, mas mahaba, mas ano dapat yun, no? Horizontal lang siya. Pero syempre, we're limited to the dimensions of the slide and the resolutions of our screen. So if you could have done it on paper, it should appear more organized, no, and not limited by space. So before we go to the actual problem, so meron tayong tinatawag pala na basis of computation. We use it to visualize the process or object in consideration. So pwede siyang unit of time or quantity, and pwede siyang papalit-palit throughout the problem-solving process kung ano yung mas convenient. But of course, kung papalit-palit man siya, you should keep track of how you change the basis for computation. Ano ba example nito? Yun nga, for example, you are having an operation, pwedeng ang basis mo is 1 hour of operation kung mas convenient yon para sa'yo, dahil binibilang mo how much can I produce in n number of hours, or kung parang may batch operation naman, may batch size. So, pwedeng yung batch size na yon, or yung meron kang isang material na yun yung basihan mo, like yung main ingredient, tapos gaano karami, kasi naka-ratio yung sa ingredient na yun lahat ng other quantities. Okay, let's give an example sa problem. Okay, so say for example, we have orange juice with 10% solids, and you want to concentrate it, evaporate the liquid para maging concentrate siya na orange juice. And then your goal is to make 300 grams of 45% concentrate or orange juice na merong 45% solids instead. So the question is how long the process would take if you can have 220 kilograms of orange juice per hour evaporated from 10% to 45%. So we start by first understanding the problem, making sense of the givens, and trying to visualize the process. So kung kailangan nyo, manood kayo ng YouTube video on the evaporation, how do they make juice concentrates, para may idea kayo sa kanya. So how do we solve problems like this, no? Although you can go straight to the math, ratio and proportion lang yan and stuff, we want to do it the right way, the food eng way, no? So bear with me and try to follow these steps na lang. So obviously we start with drawing the process flow diagram. Ito yung CO number 1 natin, which is to visualize unit operations. Okay, you have an evaporator. What it does, of course, is remove water from a dilute product to make it into a concentrated product. As I mentioned earlier, kapag gumawa ka ng process flow diagram, yung bawat input or output stream ay lalagyan mo na ng relevant information. So in this case, the concentrations of the input and output streams, as well as kung ano yung given na alam natin na quantities, which we can use to calculate the other quantities which are required. Okay, so in this case, under the left side, nandyan yung rate niya, which is 220 kilograms per hour. And then, nakalagay naman sa kabilang side yung 300 kilograms of orange juice concentrate na gusto mong gawing product. So the next step is to choose a basis for computation or calculation. So nakita natin na maraming na-mention sa product na ito. Meron kang hourly rate and meron ka ring target quantity. So arbitrary naman ito. You can actually choose either in your problem solving. Pero usually merong mas logical na basis in this case, dahil ang gusto mong hanapin ay yung amount of raw material needed for a finished product of 300 kilograms, or the amount of time needed rather, then it's best to have a basis of 300 kilograms of concentrate product. Okay, so meron tayong tinatawag na OMB or overall mass balance. Ibig sabihin lang nito, once you've drawn the process flow diagram, then you enclose it in one large box na na-enclose lahat ng processes. Yung OMB or overall mass balance ay yun lang lahat ng arrows na pumapasok at lumalabas doon sa box, at yun yung gagawin mong equation. Kumbaga, ito yung mga lahat ng initial inputs and lahat ng final outputs mo. Any intermediate input or output will be removed from the OMB. Okay, kasi output siya ng isang step tapos input dun sa next. So in this case, we have actually one process lang. So the overall mass balance is yun na rin pinaka-equation ng evaporator. And the assign arbitrary variables, usually yung medyo logical dun sa pangalan ng product para sa mga streams natin. So we have J as the mass of your 10% solids na orange juice, W as the mass of the evaporated water, and C as the mass of the concentrate, which has 45% solids. So in the previous slide, we did our overall mass balance. Now we move to the component balances. So each stream doon sa tatlo can either be composed of water, solids, or a combination of both. So therefore, dito meron tayong dalawang component na tinitingnan, which is simply your water and your solids. So let's first try to do a component balance, meaning i-account for natin lahat ng water dito sa problem natin. Okay, so first of all, you have yung juice mo is 10% solids, therefore it's 90% water. So we express that as an equation that the mass of the water in the dilute juice is 0.9% of the mass of the juice, or 0.9 J. On the other hand, dun sa concentrate mo, meron ka namang 45% solids, therefore yung 55% noon is water. So kung ano man yung mass ng concentrate na juice, 55% nun would be the mass of water in that juice. And then of course, yung water na nag-evaporate, it's 100% water. So kung ano yung mass nun, yun na yun. Therefore, if we were to account for all the water in the system or the problem, the water in the juice equals the water evaporated plus the water in the concentrate. And if you were to represent each of those with the stream variables, 0.9 or 90% of J is equal to W plus 55% of the mass of C. Okay, so we want to use the energy balance if applicable, but in our case, hindi muna natin poproblemahin yon. So let's stick to mass balance lang. And then apply any known relationships, no, assuming steady state or equilibrium. Ano ba yung iba pang mga equations na pwede mong gamitin? Yun nga, any mass balance problem is usually a problem of an n number of unknowns. And of course, you would need an n plus 1 number of equations minimum to solve them. Pero you want to visualize first before we do the math of it. Okay? So, after that, you, again, trace the steps and try to reconstruct them. Parang, ano ba yung una mong masosolve dito sa maraming mga given? Ano yung una kong pwedeng ma-quantify? And then after you quantify one of the streams or the components, you can use that to try and solve the other equations until you have your problem solved. So actually, in this case, pwede rin natin gawa ng balance yung solids, no? Pero in certain cases, it might not help. So, depende sa case mo. Okay. So, ngayon, nakita natin kanina, we already did a water balance. So, and then we chose our basis na we need 300 kilograms of concentrate as finished product. So, based on that, we will compute how many hours will I need to run the equipment so that I can get my product of 300 kilograms of concentrated juice. So here's the overall mass balance equation, and then we have here the equation for the water balance. And that, notice that this is an example of you have your two equations and you're using it to solve your unknowns. Okay, so in this case, if we try to quote-unquote add the equations, or in this case, parang sinubtract mo yung isang equation sa kabila to cancel out the W. So you now have an equation relating J to C. Okay, so in this case, 10% of J is equal to 45% of C. This is actually yung equation ng solids balance. So you can actually do it that way, no? And you'll arrive at the same thing. And if you try to isolate the equation so that you can solve for J, since C is given na 300 kilograms, you know that to get 300 kilograms of concentrated orange juice, you'd need 1,350 kilograms of dilute or 10% solids na orange juice. Now, to get the time required, you simply divide that amount needed by the rate specified, which is 220 kilograms per hour. Alright, so here's a sample problem you could try. Medyo mas mahirap ito, and it now involves a proportionator. So dito maguguluhan kayo, hindi na kaya to ng simpleng algebra lang unless you think through it, no? So you still have, for example, your 10% solids juice, but it passes through a proportionator. What this proportionator does is dinidivide niya yung 10% solids na juice into a fraction that gets evaporated, and the other fraction is added back to the concentrate during blending to get your 45% orange juice. So this is just another way of doing the first problem. Pero sa tingin niya, bakit ginawa lang ba itong problemang to para pahirapan kami, sir? Hindi naman po. In reality, may sense na gawin yan, no? Kasi evaporation is a large amounts of energy yung kino-consume niya, no? So kung ginawa mong ganito na hinati mo yung part na mag-evaporate and meron kang part na i-blend mo lang, hypothetically pwede kang magkaroon ng savings sa energy cost kasi hindi mo na kailangang i-heat up rather to boiling yung buong amount ng juice. Okay, so you're supposed to be save some energy anyway, but here comes the problem now. Again, the evaporator concentrates to 65 instead of 45, and then it's diluted to in a blender with the 10 diluted to 45% with the 10% solids juice. Okay, so conveniently naka-drawing na dyan sa inyo yung process para mas madali na. Alright, and the question is, ano ba yung proportion ng F tsaka A? No, ilang kilo yung pumapasok sa evaporator at ilang kilo yung mapupunta sa blending per hour. Alright, so in this case, I'll just provide you with the initial steps, and then you can try solving this on your own as a sample problem or a practice problem, and I'll be including the solution in the succeeding slides. Now, so we first choose a basis based on the problem. It's more convenient to have a basis of 1 hour of operations kasi nga yung hinihingi dun sa problema is per hour then. Okay, as you can see here, we have actually 1, 2, 3, and 4 boundaries, a system boundary and 3 process boundaries for the proportionator, evaporator, and blender respectively. And therefore, off the bat, we can write down 4 equations. Okay, so I've conveniently named the variables after kung ano yung nasa picture. So you have S, A, F, W, C65, C45, and then we can see here. So you have 4 equations, and then 1, 2, 3, 4, and 5 unknowns. So kailangan nyo pang gawan ito ng mga component balance para more or less ma-bring up nyo yung relationship ng iba pang variables para ma-solve nyo siya. So I recommend that you follow yung mga steps in the previous slides to try and solve this.